Okay, here are your answers to the almost 20 questions worksheet. Let's see, number one, we are going to check this volume. And what I see here is that it's marked at the tens place. It goes from 300 to 400, and this one is marked at the tens, and it looks to me like it's right on the 10. And so how do I record that? So I want to call it 310 milliliters, right? But since it's marked to the tens, my estimate is to the ones place, which means I want to show that this is my estimated value. So the way that I do that is I put a decimal point right here. So 310 decimal point, and that shows that it was marked to the tens, and my estimate was to the ones place. Okay, number two, state the number of significant digits for each of the following measurements. Here we go. I'm going to switch colors because I like the purple one. Actually, this is more like this cool. There. Okay. 0.05 liters has one significant zeros. One significant digit. It's this one. And the second one, this has 3. So remember that leading zeros never count. Leading zeros, no. Following zeros, if there's a decimal point. Okay. This next one has 2. Following zeros, no decimal point. This next one has 4. Following zeros with a decimal point. This one has 3. Remember, in scientific notation, all digits are significant. Okay, that's how that one goes. Number 3. I'll write the following numbers in scientific notation or standard decimal notation. This is going to be scientific notation. 4.5 times 10 to the, so I move my decimal point. I added 2 tens to make it 4.5. So I'm going to take away 2 tens. So it's 4.5 times 10 to the negative 2. 320.5 needs to be a number between 1 and 10, so that's 3.205 times 10 to the 2. Oops, it's not writing. 10 to the 2. 7.5 times 10 to the negative 5 is going to be, I'm going to move my decimal because this, the negative exponent tells me that it's a very small number, which means I'm going to have a number less than 1. So I'm going to move my decimal point 5 places to the left, which means I'm going to add 4 zeros. 1, 2, 3, 4, 7, 9, 0. Okay. 2.2 times 10 to the 6, that's a big number, so I'm going to move my decimal to the right. 2, 2, and I'm going to add 5 zeros. 1, 2, 3, 4, 5. So that's 2,220,000. Number 4. Need my calculator to do this. Find that. Get my calculator out here. I'm just going to do the math on my calculator. So 3200 divided by 4.184 divided by 24.9. And the answer is, oops, let me pan again, 30.7155961. Okay, this has 2 significant digits, this has 4 significant digits, this has 3 significant digits. I'm dividing and multiplying. I get 2 in my answer, so my answer is 31. Okay? Write down a unit that is used to measure length. A unit, so meters. Mass could be grams. Temperature could be Kelvin or degrees Celsius. Volumes could be liters or milliliters. Time could be seconds, minutes, hours. Okay, that's pretty straightforward. Number 6. Fill in the correct numbers for each conversion factor. What? The correct numbers for each conversion factor. I guess we could do this any way we want. 1 meter is 100 centimeters. 1 liter is 1,000 milliliters. We could say 1,000 grams is 1 kilogram. There's more grams, so I'm using kids have dropped over dead converting metrics. And I'm using whichever is further to the right for the one with the numbers, because that's what makes sense to me. So there's more as you go to the right. 1 kilometer is 10, 100,000, 10,000, 100,000. 100,000 centimeters. Okay, I'm going to go on to the next slide, or the next page. Number 7. Show work using dimensional analysis. 241 deciliters. 241 deciliters. Remember, deca would be dA. And I'm looking for the relationship between deciliters and kiloliters. And again, I'm going to use kids have dropped over dead converting metrics. And deci is right here, and kilo is here. And there are 10, 100,000, 10,000 deciliters in 1 kiloliter. So 241 divided by 10,000, I'm going to move my decimal place 1, 2, 3, 4 places to the left. So my answer is going to be, where can I put that? Equals, what's it? 1, 2, 3, 4. So 0.0241. Okay. Number 8. Kelvin equals Celsius plus 273. So 250 Kelvin minus 273 equals negative 23 degrees Celsius. Okay, 2.40 meters. What they're giving me is a bunch of conversion factors there. I'm going to set this up. I need to get from meters to centimeters. Then I can get from centimeters to inches. And then I can get from inches to feet. So I'm setting up my conversions there. So I'm going to have to use kids have dropped over dead. Converting metrics. To get meters to centimeters. Meters is here, centimeters is here. There are 100 centimeters in 1 meter. There are 2.54 centimeters in 1 inch, and there are 12 inches in 1 foot. There's how you set that up. Do the math. 2.4 times 100 divided by 2.54 divided by 12. I get 3 significant digits in my answer because there are 3 here, right? So my answer is 7.87. 7.87 feet. I'm like running out of space here. All right, the next one, 8.9 cubic centimeters. Right, and I'm going to go to inches. And here's my conversion factor here. So 2.54 centimeters in 1 inch. I'm going to do that 3 times 2.54 centimeters in 1 inch. 2.54 centimeters in 1 inch. I'm going to take 8.9 divided by 2.54 divided by 2.54 divided by 2.54, and I get 2 significant digits in my answer, so it comes out to 0.54 cubic inches. Okay. Rates 5.8 meters per second. And I want meters to go to kilometers. You can see that. And I want seconds to go to hours. So I'm going to use kids have dropped over dead converting metrics. I'm going to use this one up here, if you see it. So I have kilometers and meters. Meters is the one place. Kilometers, there are 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer. And 1 hour has 3,600 seconds. So 5.8 divided by 1,000 times 3,600 is, to 2 significant digits, 21. 21 kilometers per hour. Okay. Number 12. A density of plastic block is 0.9 grams per cubic centimeter. Block B is more dense at 1.1. If the 2 blocks have the same mass, block B is more dense. They have the same mass. That means the volume of plastic A, which is less dense, is greater than the volume of plastic block B. I could draw this out here if I wanted to. Let's just call them both. You can pick whatever you want. 2 grams. We're going to have block A, block B. Block B is more dense. So it's super dense. I'm going to try to make it super dense here. And this block is less dense, so it needs to be bigger in order to have the same mass. Don't know if that helps. Number 13, given the following data for blocks A and B, their densities and their masses. If 10 grams of water is obtained, will the block sink or float? That is a trick question. Masses are not going to matter because the density is all that's going to matter here. The density is all that's going to matter. The density of water is 1, so that means that block B is going to sink because it is greater than, and block A is going to float. If they asked us about the volume, anything about the volume, we could figure out volumes because we have the densities and the masses, and because density equals mass divided by volume. But the masses are unnecessary in this case. This is a very tricky question. Okay, I'm going to go on to the next page. Number 14. Find the volume of 64.1 gram block of copper, which has a density of 8.93 grams per cubic centimeter. So this is where we have D, M, and V. Density is 8.93 grams per cubic centimeter. And the mass is 64.1 grams. And the volume is the question mark. And if we remember our little triangle, I'm going to put it way over here. Just remember mass goes on the top, and we have density and volume on the bottom. So to calculate volume, it's going to be mass divided by density. Right? Because volume over here is mass over density. So that's going to be 64.1 grams divided by 8.93. Well, I should have done it like this. Let me erase and show you this again. Because I have 8.93 grams per cubic centimeter, it helps to set it up like that. So then grams cancels out, and I get cubic centimeters in my answer. I'm still just dividing though. So 64.1 divided by 8.93, and I had 3 significant digits, so 7.18. 7.18 cubic centimeters. That's my volume. Number 15, you're given the following measurements. The average of the measurements. So we're going to add all 3 of the measurements. 3.5 plus 3.55 plus 3.49. And since there are 3 of them, we're going to divide by 3. And I get 3 significant digits, so 3.51. And the average deviation, so that's my maximum. So the deviation, remember, is the maximum, 3.55, minus the minimum, 3.49, always divided by 2. This goes in parentheses, so your PEMDAS are going to subtract first and hit equals first. 3.55 minus 3.49 equals, divided by 2 equals 0.03. We report this data as 3.51 grams plus or minus, actually, we would report it as 3.51 plus or minus 0.03 grams. Okay, average plus or minus the deviation. Number 16. A student calculated density to be 8.51 grams per cubic centimeter. If the actual density is 8.93, what is the percent error? Percent error. Actual, so there's my actual, 8.93 minus experimental, 8.51, in parentheses, divided by actual, 8.93, times 100. So, 8.93 minus 8.51 equals, divided by 8.93 equals 3 significant digits, times 100, 4.70%. Next one, label each as, okay, this block here, I'm going to put accurate and precise. This block down here, I'm going to call precise but not accurate. This block here, I'm going to call this one accurate but not precise, because they're all pretty close to the bullseye, but they're not very close to each other. This one here, I'm going to call the bottom right, I'm going to call neither accurate nor precise, because they're not close together and they're not close to the bullseye. Okay, that's my answer for that one. Number 18. Values of density of 2 classes were obtained. Oh, this is a great question. Okay. Here are the precisions, right? Which class was more, okay. Let's see. So these are the precisions. We're going to do precision first. The precision is just which one of these values, the deviations, is smaller. And that means that class B was more precise. Okay. If the density of the block is actually 3.22, we'd have to calculate the precision, the percent error, sorry, of each estimate. So we could take, and really though, 0.20 is, 0.02 off, 0.28 is, so we could just look at this. 3.22, right? The difference between 3.22 and 3.20 is 0.02, and that's smaller. 3.28 is 0.06 bigger. So that means that class A is going to be more accurate because their average is closer to the actual. That's a quick way of doing that. You could actually calculate the percent error, but I don't think you need to. Okay, let's go to the next page. The next page is just identify how you did. So this is the part where you're going to pick up all your happy faces and figure out what you need to study next, okay? So that's the end of almost 20 questions. I hope you found that useful.